welcome back, everybody. This is the last lesson, finally, in our linear relations and linear functions section of this channel. So for Math 10, parallel and perpendicular lines is usually where we stop this, and then it gets continued on when you talk about functions in greater depth in Math 20 and definitely Math 30. So parallel lines are those ones that are equal distance from one another, and they don't ever cross. So for example, different lines of a railroad track or the opposite edges of a rectangle, those would be considered parallel lines. Now, they are considered parallel for our purpose if they have the same slopes. Okay, that's going to be very important. That means their rise and their run is the same. So they will always increase in their y direction and change in their x direction by the same amount. I guess their y's could also decrease, but they just have to be the same. So if we graph the following lines, 2x plus 1 and 2x minus 3, we'll actually just see what this looks like. So I've got my grid. Now it's easier to use the y-intercepts to plot these. So just give me a second. If I plot this one at 1, my slope tells me we're going to go up 2 units and run 1 unit. So if we go up 2, right 1, 2, right 1, you can start to see this line being formed. Now here's what that line should look like as it crosses through those points. Come on, iPad. That's close. So there you go. There's the first one. So let's say that one is y equals 2x plus 1. And the other line has a y-intercept of minus 3. And again, the same slope. So up to right 1, up to right 1. And again, you can see what those lines look like. So those are what we would consider parallel. They don't ever cross, and you can see that they have the same slopes of 2 but different y-intercepts. Okay, that's important. They have the same y-intercept and the same slope. They're actually the exact same line. So they have different y-intercepts but equal slopes. Okay, so there's parallel lines, and there's an example of what they might look like. Now, if you're asked to identify them, sometimes it's not super obvious when you're just given some points. So we're going to actually locate and find the slopes of these points and determine if they are parallel. So we're going to find all 3 slopes here. We've gotten pretty good at it over the past few videos, so it shouldn't take us too long to do this. So the slope of the line GH, so the slope M of line GH. That's what this is saying. We just need a way to distinguish between the two, or between the 3, because we're going to have a bunch of sets of points here. So the slope of G to H, and then our slope formula is, I'll write it on the side here, y2 minus y1 over x2 minus x1. The change in the y's divided by the change in the x's. So along the top, I'm going to do 2 minus negative 1, and again, purely just by choice, and then negative 4 minus 2. So the slope of GH, that line, is 3 over negative 6, which is the same thing as negative 1 over 2. So the other 2 line segments, we need to test their slopes as well to see if these are all parallel. Now, the reason I'm doing this is because I don't want to graph them all. So we can actually prove and show that they are or are not parallel. So let's find the slope of J to K. So subtract the y's again, 7 minus 3 over negative 1 minus 7. So on top, we're going to get a 4, and on the bottom, a negative 8 for a slope of negative 1 over 2. So far, we know that the line GH is parallel to the line JK because their slopes are the same. We do need to test the last pair of points as well, and maybe we'll do this underneath. So the slope of MN, that's not a good N equals, subtract the y's again, so 5 minus 1 over negative 4 minus 5. So we get a 4 on top again, and on the bottom a negative 9 for a slope of negative 4 over 9. That fraction actually can't be reduced. So these 3 slopes, while 2 of them are the same, so 2 of these lines are parallel, not all of them are. So to answer the actual question, no, they are not parallel. So therefore, no, not all lines have the same slope. Okay, in order to fully answer the question, no, they don't have the same slope. If all three were equal to -1/2, then yes, they would be parallel. And you can draw that for yourself, should you like, and should you wish. I'm just going to choose not to. Okay, here's the other case then. Perpendicular lines. Now these are the ones that intersect at those right angles, and they have a 90-degree, that's what right angle means, and are represented using the symbol, looks like an upside down T. The other symbol which you might see, looks like two lines that looks like that, that's for parallel. I don't know if it said that up there or not. But you've got your perpendicular symbol. Now two lines are considered perpendicular if they're slopes. This is the important part. They are negative reciprocals of one another. So we'll talk about a couple examples down below. That is, a line with a slope of A, where A is non-zero, is perpendicular to a line with a slope of -1/A. When you multiply perpendicular slopes together, they should equal to -1. And the reason why that happens is if I take the reciprocal of a number and multiply it with the original number, the numerator denominator end up canceling, and vice versa with the other numerator denominator pair, and there is a negative sign that remains. So -1 is where that comes from. Now we are asked to see if we can locate the slopes of these points. So from C to D, you could count out the slope as well, but as a coordinate pair, point C is -4, 8. So that's -4, 8. Point A is 7, 6, it looks like. So point A is 7, 6. Point B is 1, -2. 1, -2. And then point D is 8, -1. 8, -1. So if we find the slopes of these two lines, so C to D first, so the slope of CD, subtract the x's, 8 minus, or subtract the y's, sorry, first, 8 minus -1, and then -4 minus 8. That'll give me a 9 on the top, a -12 on the bottom. Now that will simplify to being, divide them both by 3, -3/4 is the slope of C to D. Now if we locate the slope of AB, you could also, count the rise and the run like we did before, but subtracting the y's, 6 minus -2, and on the bottom 7 minus 1. That will equal an 8/6, which will reduce to 4/3. Now if I look at those, one is negative, one is positive. One is the reciprocal of the other. So if I put those two things together then, each of these slopes are the negative reciprocal of each other. This means that these lines are actually parallel. There should be a 90-degree angle, or not parallel, I'm sorry, perpendicular. There should be a 90-degree angle in between those lines. Okay, they cross perfectly at a 90. So I guess let's say that slope C to D is perpendicular to slope AB. Wow, I can't write today. B. Because of the negative reciprocal. Okay, that's why they are parallel. One is the negative reciprocal of the other. Now if you're given a couple slopes, you should be able to identify what the negative reciprocal is going to be, because that's going to help us do a whole lot of other problems when we talk about linear equations. And I have to find the equation of a line, let's say, that passes through a given point but has to be perpendicular to another line. So they're giving me enough information to find a slope and a point, and I just have to know what the word perpendicular means and how to use it. So if I have a slope of 4, the negative reciprocal of 4 is -1/4. Flip the fraction, change the sign. Same thing for B. Flip the fraction, change the sign. It was negative to begin with, so my perpendicular slope should be positive. Do something similar for C. That one gets changed to 5/4, and again, sign change. What was positive becomes negative. Now if it's a whole number and negative, like -5, no different. Make the reciprocal, so 1/5, and change the sign. It was negative before, let's make it positive. So always change the sign from what it was to begin with, and use the reciprocal. Okay, that's what it means for a negative reciprocal. It doesn't always have to be negative. If If you start out with a negative, you could have a positive slope. Keep that in mind. Okay. Line ST is the next one here. Passes through the points S and T. Line UV passes through those 2 points. Okay, are these 2 lines perpendicular? Now, a very similar question we did when we talked about parallels. Let's find the slopes of line ST. So the slope of ST equals, and again, remember your slope formula, y2 minus y1 over x2 minus x1. Subtract the y's in whatever order you like. 7 minus negative 5 is the one I'm choosing. That means I have to go negative 2 minus 2. For a slope of, that is 12 over negative 4. So the slope of ST, 12 over 4 is 3, so that's negative 3. Now we got to find the slope of the other line segment. So the slope of UV is going to be 6 minus 3, and then 7 minus negative 2. For a slope of 3 over positive 9, for a reduced slope of positive 1/3. And you can see those 2 are the negative reciprocal of each other. So you can say now that the slope of ST is perpendicular to the slope of UV. Okay, those 2 lines are going to be perpendicular because of their slopes. Or I guess I really should say, sorry, not the slope. We should say the lines are perpendicular. The slopes are negative reciprocal. So ST is actually perpendicular to UV. The lines are perpendicular. Okay, so therefore, line ST is perpendicular to UV by showing that. And you can graph them as well, and you can see what that picture looks like. Okay, let me just take a quick stroll. Okay. So I'm going to do just number 1 here, because 2 is very similar, and I can let people try that one. So determine the slope of a line perpendicular to the line EF. So if I need, basically I have to find a perpendicular slope to this line. So I need to find the slope of this line first. So the slope of E to F is going to be 3 minus negative 1 over 2 minus negative 4. So 4 over 6, that means 2 over 3. Okay, so there's the slope of the original line. Now if we're determining the slope of a line that's perpendicular to it, we need to do something to this slope. We need to take its negative reciprocal. So that means the perpendicular one is going to be negative 3 over 2. Take the reciprocal and change the sign, which we've done. Now for B, we're asked to determine the coordinates of a new point called G so that the line formed by points E and G is perpendicular to the line formed by E and F. Think about that for a second. We already have a line E to F. Maybe it's helpful if we plot the points first. So 2, 3. And I'll zoom in here. So 2, 3. That's point E. And point F is negative 4, negative 1. 1, 2, 3, 4, 1. Did I miss? I did. Okay. Okay, so there's the line EF. Now we need to locate a point G so that the line that goes through point E and connects with G forms a new line called EG, and it needs to be perpendicular. So we need to use the slope that represents something perpendicular, and it tells me I have a rise of negative 3 but a run of 2. So from point E, I'm going to create a new point, not using the same slope because that'll give me another point on the blue line. But if I use the blue slope to represent perpendicular, that'll give me a new point totally off of this line that when I connect them, it'll pass through E and meet up with G and represent a perpendicular line. So let's move this down 3, right 2. So 1, 2, 3, 1, 2. Here's my new point. There's G. And there's the line that goes through them. G has coordinates of 4, 0. You've just created a new line in pink that is perpendicular to the original, but passes through another point. Okay, so point G has coordinates of 4, 0, and it meets E at a 90-degree angle. It is perpendicular to it. Okay, so you can try out number 2 for yourself and see how you do. And I will give you the answer, as always. Now, if we're going to write an equation of a line that's parallel or perpendicular to a given line, really this is what we just did. But now they're giving me the point. So if I use this information to write a new line, we're going to write an equation that passes through R, but is also parallel to this line. So if I have to be parallel to this line they're telling me, that means I have to use the same slope. So the slope that we need to use, so the parallel slope, is 2 over 3. And the point we need to use is 1, negative 1. With those two pieces of information, we have enough to make the equation of a line. So y minus y1 equals mx minus x1. I'm choosing this one because I know that point is not the y-intercept, so I'm going to use slope point form to do this. It doesn't actually specify which equation I need. So y, this will change to plus 1. Because remember, if it's minus y1 and y1 is a negative, minus a negative makes a positive. Equals 2 over 3 x minus 1. And there's the equation of my line. It is in point slope form. I wasn't asked to change it to another, so that is perfectly acceptable the way it is. We can do something similar for b, but this time I need to use the perpendicular slope. So the perpendicular version of 2 over 3 is going to be negative 3 over 2. The point is the same, 1, negative 1. So my line becomes, again, y plus 1 equals negative 3 over 2, x minus 1. And there's the equation of my line. We don't have to convert it. We weren't asked, so we don't need to. So let's leave it right here. And I can do something very similar for 2a. Okay, passing through a point again, parallel to one of them, perpendicular to one. So I'll leave 2 for people to try as well, and you can see how you did when you look at the answer key. So the one last thing we will do in here is this one right here. Where do I want my face to be? Let me shrink it a little bit. Give me 1 second here. Let's do that. Give us just enough space. That's perfect. Okay, a triangle has vertices at A, B, and C, and those points are listed by their coordinates below. Sketch the triangle and prove that ABC is a right triangle. Now, without the grid, it makes it very difficult to draw it perfectly, so don't worry about making your picture perfect. Now, let's just think about what this means if it's a right triangle. If it's a right triangle, they're telling you something about one of the angles. They're telling you that one of the angles, so you've got one 90-degree angle, which means 2 lines have to be perpendicular to each other. Now, the reason why we're asked to sketch this is so I know which 2 sides of the triangle to actually look at. So we're going to make a little sketch, but it's not going to be great, especially because I can't draw a straight line. But, it'll give us a good idea of where things happen to be. So there's our grid. A is negative 2, 3, so negative 2, and 1, 2, 3. A is somewhere here. B is 8, negative 2, so 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, here's B. And C is 4, 6, so 1, 2, 3, 4, 3, 4, 5, 6, here's C, roughly. Okay, not perfect, but does what we need. So here's my triangle. And again, not perfect, but it does give us something we need to look at. So we're trying to prove that this triangle is a right triangle. Now it looks, based on where the points are, that it looks like my 90-degree angle should be on point C, which means the 2 line segments which I need to take into account are line segment A to C and C to B. In order to prove that this is a 90-degree angle, I need to prove that those 2 line segments are perpendicular to each other. And in order to prove they're perpendicular to each other, I need to know the slope between the 2 points that create it. So we're going to go find the slope of AC and then the slope of CB and compare. So from the points A to C, use your slope formula again, which here it is. Same thing as before. So same slope formula. So 6 minus 3 is what I'm going to do. That direction, 6 minus 3. and then 4 minus negative 2. And this will give us a slope of 3 over 6. So the slope of AC is 1/2. Okay, so then we'll check the slope of CB to see if they're perpendicular. So C to B, so 6 minus negative 2. And then on the bottom, 4 minus 8. Did I do that right? 6 minus 8. Yeah, I did. So 8 over negative 4. So the slope of C to B is negative 2, which is absolutely the negative reciprocal of the other one, which means that this is a right triangle. So therefore, triangle ABC is a right triangle, since the line segment AC is perpendicular to the line segment CB. That creates that 90-degree angle for me. This is a right triangle. So that brings us to the end of relations and functions for Math 10. Parallel perpendicular lines. So check in the description. You will have the answer key for those couple that I didn't do, and you can check them out. You can reach out to me on, you can send me an email, as a couple people have done already, which is fantastic. You can follow me on Instagram. You can follow me on Twitter. The links are in some part of the channel section. You can find them. Mr_Saw, S-A-W-H. And you'll notice that all of the other sections for this course, the systems of equations and trigonometry, they're already up there, so you can take a look at those as well. So I hope that this has helped you out at some point, and it is nice to hear from you. So please let me know. But until then, take care, and I hope you have a wonderful rest of your day. Bye-bye.